everyone, welcome back. In this particular video, we will be discussing the problem find largest subarray with sum 0. The problem is given an integer array, find the largest subarray. Largest means longest here. Longest subarray whose sum is a 0. If there is more than one subarray with the largest length, the longest length, return the subarray with the lowest starting index. So if there are multiple subarrays whose sum are 0, among all those subarrays, pick the first particular subarray or pick the subarray whose starting index is the minimum. And if there is no such subarray, in that case, we have to print -1. So let's just take a sample test case to actually understand what is the problem asking us to do. If there are 6 elements, 2, 3, 1, -4, 0, 6. Let's just take 2, 3, 1, -4, 0, 6. We need to print what? We need to find the subarray whose sum is 0 and the longest such subarray. So one subarray whose sum is 0 is of course element 0 itself. But what is the length? In this case, the length will be 1. If I talk about a subarray containing 2, 3, 1, the sum will be 5. 5. Actually, if I do not take 2, then that case sum will be 4. This sum was not 5, but actually 6. But in this case, it will be 3 plus 1, 4. 4 minus 4, if I will take this entire subarray, the sum will come out to be 0. So this is also a subarray whose sum is 0. The length is 3. But what about taking 0 also and this particular subarray also? This entire 4 elements, if I consider together, they are also the subarray, but their length will be 4. So the longest subarray will be of 4 length. What do we need to print? We need to print all the elements in those subarray, or we have to find the subarray itself. That is the answer in this case will be 3, 1, -4, 0. And if there would have been no such subarray, in that case, according to the question, we have to print -1, only element -1. But what if I take the subarray? Let's take a array, not a subarray. This is example 1. Let's take example number 2, which is 1, 2, 3, 4, 5. In this case, is there any subarray whose sum is going to be 0? Of course not. All the values are positive. For a subarray whose sum should be 0, at least there should be a 0 element. Or you can say at least there should be a value which is negative. Then only there can be a 0 sum subarray. In this case, since there is no such subarray, output should be -1. This should be the output. This is one corner case. But there is one more corner case. According to the question, there might be multiple subarrays whose length is longest and who are having 0 sum. So if I take a test case where I am saying 1, 2, 3, -5, then let's take 4, or maybe let's take 10, then let's take 4, let's take 1, let's take -5. If this is the array I am giving to you. So what if I take the subarray 2, 3, -5? This sum is also 0. What if I take the subarray 4, 1, -5? This sum is also 0. So this is also of 3 length. This is also of 3 length. And there is no other subarray of more length than 3 whose sum is 0, because in between there is element 10. Now there are two subarrays who are having same length and 0 sum. So both are satisfying the condition. But among them, which one to select? According to the question, we have to select that subarray whose lower index is first, or you can say the first subarray we have to take. So in this case, we have to take this one, not this one. So we will print 2, 3, -5. So this is the corner case number 2. Now the point is how we will actually solve this problem, how we will find all those subarrays whose sum is 0, and among all of them, we will find the subarray with the longest length. See, if we need a subarray of 0 sum, there is a property associated with 0 sum subarray, which we can use in order to reduce the time complexity from brute force. What can be a brute force solution? Brute force can be just simply find all the subarrays one by one. That is, run a loop for starting point, run a loop for ending point, check what is the subarray sum, and if it is 0, find the length between starting and ending, and just store it in an answer variable, and finally return that answer variable. But that approach, brute force approach, since we are going to have two loops which are nested, the overall time complexity will come out to be n into n square. The optimization, in other hand, will be less than n square, and that will be based on a property which is based on prefixes. So if I take a array, which is, let's say, the values are 2, then 3, then 1, then let's take -4, then let's take maybe a value which is 0, then let's take 6, let's take having value 5, let's take value having 1, let's take a value having, or let's take have value which is 7, and then let's take -13. So this is the entire array given to us. I am taking a longer array so that all the corner test cases are getting covered. Although in this test case, there will be subarrays whose sum will be 0. So this particular test case will not be covered, but this is very easy to detect. If there will be no subarray, length will remain 0. If length will remain 0, just return -1. Just have a answer array list or answer array, a dynamic array where there will be a single element -1. That is easy to take care of. But let's just have a case where there are multiple subarrays whose length are same with 0 sum. First of all, what is the property? If I talk about this particular array whose sum is 0, 5, 1, 7, -13. What is the sum of this array? The sum of this array is 0. What will be the sum of all elements till the previous index of the starting index? If I say this is the starting index, if I say this is the ending index, or let's say this is the left index, this is the right index, the sum till left -1, whatever that sum is, let's say x sum, whatever it will come out to be, sum of 2 plus 3 plus 1 minus 4, 0, 6. And the sum from 0th index till the rightmost index of the subarray, it will also come out to be x plus 0, which is x only. This is the special property of the zero sum subarrays. The sum, or particularly the prefix sum, because the subarray is starting from 0, the sum is starting from 0. So prefix sum till left -1 index will be coming out to be equal of the prefix sum till the right index. And in this manner, we will be able to figure out the left index and the right index. Once we know where is the subarray starting, once we know where is the subarray ending, we will also be able to return that subarray. So we will only store 2 pointers of the longest subarray, that is a starting pointer and the ending pointer. And we will be able to find out the length using that. If I ask you what is the length of this subarray, it will be 9 minus 6, 3 plus 1, right minus left plus 1, 4 length subarray. So this is the property which we are going to use. Now, since we need to find whether there is a prefix sum already existing and it is repeating, we have to maintain some visited data structure where we will store all the elements whether they are already visited or not. But this time, since we need to also store where is the x sum present, it is present at 5th index. Now where is it repeating? It is repeating at 9th index, so that we can also find the subarray. Subarray will be from 5 plus 1 till 9, from left -1 plus 1, that is from left index till right index. So we have to maintain a data structure of key value pairs. Why? Let me repeat again. We have to check whether a key is repeating or not. If a sum is repeating, a prefix sum is repeating, there is a zero sum subarray, and that is what we need to figure out. But we don't only want to check whether a sum is repeating, we also want to check where is it repeating, or where is it basically present. Where was the previous sum and where is the current sum? Between that indices will be the subarray whose sum is 0. And due to this, we need a data structure of key value pair where searching is very efficient. You can say constant time in average case. And one such data structure which you can use actually is a hash map, or you can say a hashing algorithm of key value pairs. Key will also be integer, value will also be integer. Why? Key will be the sum are integers. Value will be the indexes are also integer. So initially, what we can say? We can say that the data structure of hash map is empty. There are no key value pairs or there are no prefix arrays. Although we will see whether we should have any prefix array or not. But right now we are just starting with an empty hash map. And we will just keep on pushing the new hash maps as and when required. And we will also try to maintain what is the current prefix array sum, because we will be running a loop for all the elements one by one. We will go over each and every element and check what is the new prefix sum. So initially the sum will be 0. Initially this hash map, which is going to contain all the prefixes sums, will be empty. And also the answer length. For answer, we need to only store the left pointer and the right pointer. That is where is the subarray starting, where is the subarray ending. For now, we can assume it is starting from -1 going till -1, like it is empty. You should not consider it from 0 to 0, otherwise you will consider element 0 index having value 2. It is not zero sum. So just initialize with anything apart from 0, apart from any index in the array. So I'm initializing it with -1. So starting the logic, 0 plus 2 sum is a 2. Is a 2 already occurring? No. But now it is occurring at which index? At 0th index. So key will be the sum 2, value will be the index 0. Next value is 3. First of all, add in the sum. Sum will come out to be 5. Is there any prefix array whose sum is 5 already existing? No, there is no prefix array. But let's push it now. The sum is 5 and the value, the key is 5 and the value is first index. That is 5's prefix array is present at first index. Then 5 plus 1 is 6. 6 is also occurring for the first time. So 6 will be present at second index. 6 minus 4 is nothing but 2. But as you can see, 6 minus 4, 2 is already present, and which is present at 0th index. It means after 0th index, till the current index, whatever we are currently processing, the subarray is of 0 sum. Since the current sum is 2, 2 is also there in the hash map. It means 2 is repeating, the prefix sum is repeating. That is nothing but the property which we discussed about. So this particular array after 0th index till current index is of 0 sum. So what we will do, we will take this value which is 0, we will take this current index 3 and store it in the answer, because right now the answer is of 0 length, but now we will say the answer will come out to be from 0 till third index, that is of length 3. From 0, not actually from 0, but actually from 1, because left index will not be containing this particular left -1 element, that is 2. The subarray is this which is having 0 sum. So we will have the left index as 0 plus 1, which is first index. Now we will continue. Should we update this value? Should we say that now the prefix array having sum 2 is present at third index? Actually not. Why? Because if we will again have any prefix array whose sum will be 0, better will be to take the smaller left index, because in the question it was mentioned to take smaller left indices if there is a tie, or even if we don't have a tiebreaker, still we should have longer subarrays, and we will get longer subarrays only when left will be smaller, right will be larger. That is having a longer subarray. So we will not update this value. We will not say that the sum is a 2, the sum is a 2, so take the third index instead of 0. No, let it remain 0th index only. As you can see, sum is a 2. 2 plus 0, still it comes out to be 2. 2 is already there at 0th index. So this subarray from the 0th index after it till the current index is also of 0 sum. This is 0, this is also 0, 0 plus 0 is also 0. So we will update the answer because it is of bigger length. 4 minus 1 plus 1 is larger than 3 minus 1 plus 1. So we will say left will become 1, left will become 0 plus 1, that is 1, and right will become 4 this time. So left is still 1, but right is becoming 4, a longer subarray of 0 length. And again, should we update the answer, the index as fourth index? No. Longer the array, smaller the left index, bigger the right index. Value is 6. Sum will come out to be 2 plus 6, which is 8. 8 is not there. So now push it in the data structure. If it is occurring for first time, then push it. 8 plus 5 is 13. It is not there. Push it for the first time. 13 plus 1 is 14. Push it for the first time. 14 at 7th index. 14 plus 7 is nothing but 21. Present for the first time. Push it in the data structure. 21 minus 13. Now what is 21 minus 13? We can say it is nothing but how much? Value should be, I think, 21 minus 13, or you can say 20 minus 12. It will be 8, I guess. So is 8 already present? Yes, 8 is already present. It means from the 5th index, after 5th index, till the current index, till the 9th index, there is a subarray whose sum is 0. If I just add in the sum, I just missed all writing. Like I just had added all of these values, but not wrote in the sum. This particular sum is nothing but 8. 8 is already there in the hash map. From 5 plus 1 till 9, there is a subarray of 0 sum, but length is 9 minus 5 plus 1, 9 minus 6 plus 1, we can say. So what will be 9 minus 6 plus 1? 9 minus 6 plus 1 will be 4 length. but already the answer is of 4 length. That is 4 minus 1 plus 1. 4 minus 1 plus 1. It is already a 4 length. This is also a 4 length. Should we update the answer? Answer is no. If there is a tie, take the previous subarray only. So if there is a tie, don't update the answer. If there is a same length subarray whose sum is 0, let it be the previous subarray itself. So finally, we are able to say that the answer is from first index till fourth index. Just take all of these values and just store them in the array which we have to return. That is, answer will be 3, 1 minus 4, 0. That we have to return as output. What will be the time complexity of this approach? Since we are going to run a simple loop over all the elements one by one and keep on storing them in the hash map, storing in the hash map or fetching from the hash map, that is finding whether a key is present in the hash map, will take constant time in average case, but running a loop over the array of n size will be linear in nature. So overall time complexity will come out to be order of n. And what about the space complexity? Since we are going to have a hash map of n key value pairs in worst case, the overall space complexity will also come out to be linear. So linear time, linear space solution, we have covered almost all of the corner cases, but still there are 2 corner cases according to me which are left. So better will be we will discuss them at this moment only so that we don't get them later on. One corner case we already discussed, that is if 2 subarrays have same length, we have to do a tiebreaker with taking the previous answer only. But one more corner case is, what if there is a prefix itself whose sum is 0? Actually, there will be only one corner case left. Or maybe if you will consider this also, there will be 2 corner cases left to discuss. So if I take a array 2, 3, minus 5, 6, initially the hash map will be empty. Hash map will not have any key value pair. We will say the sum is a 0. 0 plus 2 is a 2. 2 is not present. So put it at 0th index. Then 2 plus 3 is 5. 5 is also not present. Put it in the sum. Sum will be 5. 5 is present at first index. Now 5 minus 5 is of 0 sum. 0 sum is also not present. So you will say 0 is present at second index. Then 0 plus 6 is 6. 6 is also not present, which is, you can say, at present at third index. But is there in no subarray whose sum is 0? Actually, there was. The prefix itself was of 0 sum. The prefix itself was of 0 sum till the second index. So what we need to do, we have to push the initial 0 which we had in the hash map already. Before running the loop, we should already have 0 present at which index? Present at the previous index to 0, present at -1 index, because previous to 0, there will be -1 index. So 0 initially is present at -1 index, so that now when it comes at the second index, so that now when the sum again comes to be 0, if I just repeat the logic, if this sum again comes out to be 0, 2 plus 3 minus 5, 0 is already present. So what will be the answer? Left will be -1 plus 1, 0. Right will be the current index 2. And the length will be 2 minus 0 plus 1, which is 3 length. So this particular subarray from 0 till second index will be the subarray of 0 sum. So one corner case we discussed is, initially before running the loop, we should push a key value pair 0, -1 already in the hash map. If not, the entire logic will go wrong, because if there will be any prefix itself whose sum is 0, we will not be able to catch it if we are not pushing this particular key value pair. So this is ensuring whether prefixes are considered or not. So to consider prefixes, push 0, -1 key value pair. And what about the corner case where there is no subarray whose sum is 0? The hash map will initially have 0, -1. We will say 1 will present at 0th index. 1 plus 2, 3 will be present at first index. 3 plus 3, 6 will be present at second index. 6 plus 4, 10 will be present at third index. No key value pair is getting repeated, or no key is getting repeated. Hence, there is no subarray found of 0 sum. Hence, answer initially, if we are initializing as left -1, right -1, we can check whether left remains -1 only. If it remains -1, it means empty subarray was there. And in that case, just return a single element containing -1. So this corner case, we have to handle after the hash map loop, or after the entire logic is done. So now with that, we are good to go with the instruction manual. The approach was very lengthy, but it was very, very important because we have to do it in linear time. So what we are going to do is, we are going to create a hash map because we need key value pairs, we need the indices also, we need the length. Create a hash map of what? Of integer key and integer value itself. Integer key and integer value. Let's say the hash map name is prefix, because anyways we are going to store prefixes. Create a hash map prefix of integer key, integer value. Initially it will be empty, but we need to push one key value pair. So add a key value pair, which is nothing but 0, comma -1. Sum is 0, index is -1, that it is ending at -1 index. Actually it is not there. There is empty subarray in the hash map, in the prefix hash map. And start the subarray loop, start the prefix array loop. So initially set the sum as 0, integer sum to be precise. And now run a for each loop, run a for each loop over all the array elements, val. One by one take those values, add in the sum. So add value in the sum variable. Once we are going to add it, we will check what is the new sum. Is it already there in the hash map or not? If it is already there, then there is a subarray of 0 sum. So check if val is present in hash map. If it is present, then we have found a subarray starting from the value of that key. So we will check what is the value. Value will be, we can say, get the value from hash map where key is nothing but sum, because we are just having the prefixes as the keys. From this particular value, we can say from next index. If I just say that the hash map was containing 0th index, and we are again getting a subarray whose sum is a 2, then it means that from 0 plus 1 index, that is next index onwards, till the current index, we have a subarray whose sum is 0. So don't store the value, but store the value plus 1. So get the value and store it, and store value plus 1 in the left variable, in the left integer. What will be the right integer? Right integer will be the current index itself. Check what is the length. If the length is better, update the answer. So we will say initially what is the answer. Initially create two integer variables, two integers, which are answer left and answer right. Initially both as -1. Now check what is the current length. If the current length is better, then update the answer. If the length, that is right minus left plus 1, if right minus left plus 1, and what is right? Right is nothing but the current index. So if we need the current index, actually we have to run a for each loop. Instead of a for each loop, we have to run a simple loop, a simple index based loop. So run a for loop over all indices. Let's say the indices name are right from 0 to n-1, because we will be getting the right indices. So add value of array of right in the sum. Check that value whether it is present in the hash map or not. Check sum is present in the hash map actually. If sum is present, get the value of that key and store it in the left variable. Value plus 1 should be stored in the left variable. If right minus left plus 1 is greater, strictly greater, it should not be equal. In equal case, we have to not override the value. If this answer is better than the previous answer, that is answer right minus answer left plus 1, in that case, what we need to do? We need to make the updations. We need to have the current value. So what we will say is, we will say just set the answer left as left, set answer right as right. And once we are able to set it, we will continue. But if the sum is not present, then we have to push it. If the sum is not present, then add the key value pair. Add the key value pair as the sum, comma the current index, the right index. The current index is right only. But this is the entire pseudocode where we are not ensuring the corner case. What is the corner case? If the subarray does not exist. So in that case, I am initially having the answer as -1, So we can say for in the last, if the left index is not -1, if the answer left is not -1, then store all elements from answer left to answer right in vector or in answer array list, in answer dynamic array, you can say answer dynamic array, answer array list, and return it and return it. But if the answer is -1, then what we have to do? Then we have to just have a single element -1. Else return an array containing -1 element. Because in the question it is mentioned, if there is no such subarray, print -1, or you can say return -1, return a subarray having -1. So with that, we are able to do all the corner cases. For initialization, you can also do what? You can have answer left as -1 and answer right as anything lesser than answer left. So that length will come out to be negative. So maybe you can just have this index as a -2 or something, or maybe -infinity will also work. We will be writing the code for the problem find the largest subarray with zero sum. So for this problem, we have already discussed in the approach part that we have to create a hash map. In Java, what we can do is we can write hash map, angular brackets, integer comma integer. Key is also integer, value is also integer. Hash map name is prefix. And now what we are going to do is we are going to just push one key value pair already in the hash map, which is nothing but 0 comma -1. Sum is 0 and the index is -1. Now we have to start the loop. In order to start the loop, we have to maintain a sum variable, which will start from 0, and answer variable, the subarray answer, that is answer left and answer right. Answer left should be -1, answer right should be -2, although you can define it anything with the negative length. You should have such a subarray whose length is negative or 0 something. So we have to run a loop for all the indices. Index based loop will work, not the simple loop. And index name we are using right because we will be just having the current index as a subarray ending or the prefix ending. So right pointer will start from 0, go till less than n, right pointer plus plus. We will check what is the new sum by adding in the current value. So we will add the right value in the sum. And after adding it, is it present in the hash map? We need to find out. So if this sum is present, how to check whether a sum is present in hash map? The hash map name is prefix. If prefix pref, if pref dot contains key, the current sum is present. If it is true, it means the sum from the previous index till the current index is of 0 sum. In this case, get the previous index in the left variable as the prefix dot get the sum value. Get is the function to get the value from a key, but don't get the value, get the value +1, that is add 1 in it. Because if, as discussed in the approach, if the hash map is containing 0th index, don't take the subarray from 0th index, take it from first index, from the next index onwards. That's why we have to do +1. Now we have to check whether this length from left to right, is it more length or not? So if the right minus left +1, is it having length more than answer right minus answer left +1? If it is, then we have to update the answer of answer left and answer right. That is, it is a better length subarray of 0 sum. So answer left will become left, answer right will become right. And if the current subarray is not present till now in the hash map, in that case, in the else scenario, what we have to do is we have to add it in the hash map. So we will just add it by using prefix dot put is the function, the sum comma the right index. So this big loop will do the entire working. Hopefully it will give me the correct left index and right index. For now, let's just print. Instead of creating the array list, let's just print the answer left space answer right. What is the starting index? What is the ending index? And for now, let's just only return a empty array list because they are expecting a array list to be returned containing that subarray elements whose sum is 0 and the length is longest. But for now, let's just print the subarrays starting and ending index to confirm whether it is working fine or not. So for this sample input, 1, 4 is the answer. That is the subarray starting from first index going till fourth index. Yes, it is having elements 3, 1, -4, 0, whose sum is 0. So this logic will absolutely work fine even for corner cases. Why? Because we have handled the corner case by already putting 0 sum in the hash map. Let's just check whether the left answer is -1. If it is -1, it means it is a corner case. If it is not -1, then we can do what? We can just store all the elements in an array list. So we can say, let's create an array list which will store all the elements from answer left till answer right, because we have to return the elements in the subarray. So from answer left till answer right, we will run a loop and we will just say result dot add is the function to append in the last the current element, that is array of index, and we will return this resultant. However, in the corner case, if the answer is -1, then just return a element -1. So in that case, we will create a array list which will initially be empty. Although we don't want it empty, we want to add an element which is -1 and return that single element -1. So let's run it again now to see if it is now working with the subarray being printed or not. The code is very large. The subarray for a simple test case is working. Let's just have the two corner cases where the prefix itself is having zero sum. So if I take maybe, let's have the element, this value, which is of two value, let's take 0. So that the prefix itself, this entire prefix itself is of zero sum and it is also the longest. So it should give me 0, 3, -1, something like that, whatever the values were. 0, 3, 1, -4, 0. What if I take multiple subarrays whose sum are 0, which are of same length? Let's just have in between 100 so that there is a breaker. So this particular subarray is of 4 length of 0 sum, and let's just have another subarray of 0 sum, which is this particular subarray of 4 length. But the answer which we have to take is the first subarray itself, not the second one. So let's just have the array of 9 length. These elements are equal to 9. So this is also 0 sum of 4 length. This is also of 0 sum of 4 length. We should have to return the first one. 0, 3, 1, -4 should be the answer. Let's see if it is going to give me that or not. That is, in the tiebreaker, we are not updating the answer. And yes, it is absolutely working fine. How about if there are no subarrays of zero sum? How about all the values are positive? 1, 2, 3, 4, 5. This was also a corner case we discussed in the approach. Let's see if it is also going to work fine or not. So it is taking some time to run. It is also working fine. It is showing you -1 output itself. Let's just submit it to see if it is going to work for all the test cases or not after handling all the corner cases. So as you can see, let me just bring the code in the notes so that you can take a screenshot or something. For later on, you can maybe go through this code once again to get the proper understanding. But this is the first part where we are actually running the loop and maintaining the hash map. And this is the second part where we are using that answer left and answer right variable to print that subarray, because we are not expected to just print the length, but expected to print the subarray itself. So this is the entire code of how much time, how much space, the time complexity. First of all, this loop is of n time. In this loop, we are having a contains key function, which is to find whether a key is present in the hash map or not. Average case constant. Similarly, get operation is to get the value from a key. Again, average case constant. And the put operation is also average case constant. So this loop is having just constant operations inside it. So overall loop will be linear, plus the subarray loop to print the subarray or to store the subarray will also be linear in worst case. So overall time complexity will be 2 times linear, but still linear. What about space? Since we are creating a hash map, which is extra space, not given in the input, not in the output. So due to this hash map data structure, we are taking linear space, because in worst case, there can be n pairs in the hash map data structure. So linear time, linear space solution, although the code is large, but this problem is a follow-up for the problem checking whether a zero sum subarray exists or not. This question was largest sum zero subarray. There can be a question where instead of largest sum, you have to find a count of the zero sum subarrays. How many zero sum subarrays are there? That can also be a different question, which you can take as a homework or as a follow-up. So till then, we are ending this video. We will meet in a new video with a new problem. Bye bye. Take care. Keep coding.